So a grammar for a language is the generator of the entire language. With grammar, we must be able to generate each and every valid string within that language. Then an automata, which is an acceptor or recognizer for that language, must accept all the valid strings in that language and should reject all the other possible strings. For example, if we have an automata which is an acceptor for the language L1, set of all strings of length 2. If any of these four strings are given to automata, then automata should say yes. If any other string is given, automata should say no. Thus, automata should accept any of the valid string within that language and should reject every other possible string. As we have seen, automata is a mathematical model or an abstract representation of the computing machine, and it is basically a state machine, and hence it can be represented by using a state transition diagram. The states are represented by circles and the transitions are represented by arrows. In the very beginning, automata will be in some initial state. We will provide some string to automata. It will take the symbols from the string one by one and move from one state to another and finally ends up in one particular state. If that ending state is an accepting state or final state, it means that string is accepted, otherwise that string is rejected. For example, this is an automata for our language L1, set of all strings of length 2. Suppose we give the string AB to automata. In the beginning, automata is in some initial state. It reads the symbols from the string one by one. The first symbol is A, so automata will move to this state. The next symbol is B. For B, it will make transition to this state. After reading the entire string, automata ends up in this state, and this is an accepting state or final state which is represented by this double circle. So it means the string AB is accepted. Now suppose the string ABA is given to automata. In the beginning, automata is in this initial state. It reads the symbols from the string one by one. First symbol is A. For A, it will move to this state. Next symbol is B. For B, it will make the transition to this state. Again, we have one more symbol A. For A, it will make the transition to this state. After reading the entire string, it ended up in this state, but this state is not a final state or accepting state. It means the string ABA is rejected. Similarly, for every string of length 2, this automata will end up in this final state or accepting state. For every other string, it will end up in some other state. It means only the strings of length 2 are accepted by this automata. Hence, we can say this automata is an acceptor or recognizer for our language L1. Similarly, for every language, there is a corresponding automata which can accept the language. So like we classified the languages into different classes and we classified the grammars into different types, we can classify automata into different classes. The automata which act as the acceptors for regular languages fall under the class called finite automata. Then we have a class of pushdown automata. Then we have a class of linear bounded automata. And finally we have the class of Turing machine. From the diagram itself, we can see every finite automata is a pushdown automata, every pushdown automata is a linear bounded automata, and every linear bounded automata is a Turing machine. And a language accepted by a finite automata is always a regular language. Then a language accepted by a pushdown automata is always a context-free language, and the context-free languages can sometimes be regular language too. So we can say a language accepted by a pushdown automata is always a context-free language, and sometimes it can be a regular language too. Similarly, a language accepted by a linear bounded automata is always a context-sensitive language. Sometimes it can be context-free language and sometimes it can be regular language too. And the same here. So in the next module, we will be discussing about finite automata, the languages accepted by the finite automata, which are the regular languages, and the corresponding grammar, regular grammar.